Right, now we're going to have a look at a tech-active application of finding the area under the curve. My first bit of advice to you is that when using your calculator to find the area, you are less likely to make an error if you use a difference function methodology than if you use the two separate functions. Let me show you. Let's start with the difference function. Remember, when you use a difference function, your limits of integration are your x-intercepts. Okay, so if we put in the two functions as we had, we've got f of x is x plus 1, x minus 1, x minus 2, g of x is 4x squared, take 8. So I'm going to have f of x minus g of x. Okay, so I'm going to have x plus 1, x minus 1, x minus 2, and I want to subtract from that 4x squared minus 28. So I just enter it as there are two separate functions, one minus the other, execute and draw. Okay, now I can't see the whole of the top function, but I can very easily see my x-intercepts, and I can solve for them using roots. I can zoom out, I can see the whole function very nicely, and if I find the roots, I can see very nicely -2 to 3, and then from 3 to 5 I can see I've got a positive, I've got a negative, very, very clear. Now what I want to show you next is this. I'm going to delete this, okay? And I'm just going to put the two functions in separately, and I'm going to find their intersection points, because that's the other way to do it, right? You draw each function separately and you find their intersection points. So we have x plus 1, x take 1, x take 2, and my second function was 4x squared take 28. Right. And I'm going to draw this thing, and oh, that looks okay. I can see that I have, let's just zoom in a little bit. Alright, cool. I have an intersection point somewhere down there, and I can go G-sol intersect, and can you see it's at -2, and if I use my right arrow I've got another one at 3. But watch this. If I zoom out, let me that, I don't know why it doesn't let me zoom out with that thing there, but if I keep on zooming out and I go up, okay, I've now zoomed out quite far, and my intersection points are -2, 3, and oh, there's another one up at x equals 5. Now if I hadn't zoomed out enough, I would have missed that entire section of my integral. Alright, this has happened in exams before where students don't see part of it, and then they lose that whole section of marks. Okay, so my advice would be to use your difference function. Okay, so 4x squared minus 28, and I'll just delete that one. And now we've got our difference function there, and it's quite a nice easy one to sketch, and we can put our values in. Alright, so maybe that's not too bad. Alright, so now we're going to sketch our function. We're going to say, using our graphics calculator, so what we're first going to say is, well, okay, we have f of x, which is x plus 1, x take 1, x take 2. We have g of x is 4x squared minus 28, and we're going to say using the difference function. Here we have that d of x is going to be f of x minus g of x, and that's going to be x plus 1, x take 1, x take 2, minus 4x squared minus 28. Alright, and then we're going to say, using graphics calculator, and this is a sketch. It is a neat sketch, but all you're actually interested in are your x-intercepts, okay? And you're going to find that by on your calculator going g-solve roots, and we're going from -2, 3, and then 5. Okay, so we're going to make sure that we've got -2, 1, 2, 3, 4. My line wasn't quite long enough, but there we go, there's 5. I can extend that black line. Okay, and we've got -2, -1, 1, 2, 3, 4, 5. We know we've got an intercept there, we've got a point there, we've got a point there. We label them. Now we've used our calculator, so it doesn't matter, we don't have to worry about our y-intercepts or anything. It's about visualizing what this area looks like, or these areas. So we're using our calculator, we're sketching our graph, okay, and we are labeling what our areas are. So that's area 1, and that's area 2. Okay, now we're using our calculator to do this. So all we're going to do is say, well, my total area is going to be area 1 plus area 2. And that's, now, you don't have to actually do the integration. What you have to do is show that you understand what's happening. So you're integrating from -2 to 3. Now this is a positive area under above the x-axis. So it's going to be -2 to 3 of d of x dx, and be careful now, from 3 to 5 it's below the x-axis, so you can either say plus or -1, or you're subtracting the integral from 3 to 5 of d of x dx, and that will be, now let's have a look on your calculator. There are a few ways of doing this. Okay, you are going to go g-solve integral. Okay, now have a look at what it says. You can either just find an integral, or you can use the roots, or you can work with intersection points, or you can work with a mix of roots and intersection points. Now because we are working with a difference function, we're interested in the roots. So if we go roots, and you'll see it immediately goes to the most left-hand root. If you just hit exe, it says there's set lower limit value, and it sets that. Now I want my upper limit value. Okay, I'm going to go all the way to the end, okay, and hit exe. Now you need to notice the integral value is 85.75. Can you see this little colored in area over here? This is your area under the curve, because remember the negative area cancels out some of the positive area. Okay, so you need to be super careful that you don't copy down this 85.75, because that is not the value of the integral. In fact, what you might be better doing is doing the following, saying g-solve integral root, and doing from -2 to 3, and putting that in. So it's, can you see the area and the integral are the same? 93.75. And then you integrate again roots, but now we're starting at 3 and we're going to 5, And you'll notice the integral is -8. Okay, so negative 8, and that gives me my total of 101.75 square units. Okay, what you can also do, just showing this to you on your calculator, you can do it in run menu. Okay, so you go option calc, and we want to integrate. Okay, and we're going to integrate our d of x, which is x plus 1, x minus 1, x. Maybe this takes longer than doing it the other way, but I want to show it to you anyway. 4x squared minus 28, and we first want to say we're going from -2 to 3. You need to be careful that you don't go all the way up, because it will only give you the 93, and that gives me a value of 100.41. Okay, and then we're going to subtract. Now you can do it, I suppose do it in the whole thing, but anyway, otherwise then what you do is you do the same thing, and you go from 3 to 5, and notice it should give you, somewhere I went wrong with something. It should have been 93.75. I think I've typed in something wrong here. That was an x minus 2. Minus 2. Okay, there's your -8. And obviously the previous one was wrong because I didn't have the right values in. So -2 to 3. There we go. That's our 93.75. Alright, so there are a variety of ways you can do it with your calculator, but basically that's all the communication you need. But if it says anywhere in the question use calculus, you need to show all of your integration. Okay, even if it's tech active, and if they say use analytical or algebraic techniques, you show all your working, including all of the substitution.